acids, bases, and acids, bases. Let me just allow this one to stream. Yeah. So because we do not have another topic of acids, bases, and salts in Form 3, we just keep on to the Form 4 class. Now, the only similarity between these acids, bases, and salts, when we associate it with the Form 3 work, is we'll be talking about the bases, or uses of bases in testing of ions, mainly the cations, which is actually, I think it is in the mole. So basically, we will touch on those ones, but we don't touch really a lot of it. But the good thing is, the test for cations is again repeated in Form 4, which is in this topic now, which I think we will deal with. We normally, when I'm teaching the normal students, most of the time, we just refer to the Form 3 work. But in our case now, we just have to do it, everything. So this one is the introduction. Actually, these are the things that we're going to discuss. So the topic outline, I'll share the notes with you. I think I'll share the notes with you. I'll share these notes with you. I'll also send topical questions, all from for now. Topical questions. I just want to share them so that anytime we finish a topic, maybe you just go through them, or maybe we'll be doing even examples from that section. Now, so the topic outline, what we're going to do, number one, we're going to define acids. For definition, we have the strength of acids, how acids normally affect solids, or how solids are normally affected by acids. We'll talk about that one. We have also bases. We have the definition. We must give the definition, which I know we had given previously, but we'll still give another one. But it is the same thing. Actually, it is the same. Strength of the bases, again, we'll discuss. We have the role of solvents. That is how solids are affected by bases, or how bases affect solids. So we'll discuss that one. And then we have now, there is I think, I don't know if it was last year's exam or the other year, they actually asked the Brosted-Lowry definition of acids and bases. I think we'll touch on that one. And then now we go to, this one is a continuation of bases. Actually, amphoteric oxides, most of the oxides are bases. Most of them are bases. So we'll be talking about the types of oxide reaction, of course, formation of complex ions. Complex ions again is in Form 3. So, but now we'll talk about it here, and then when we be in that topic in Form 3, no problem. We just touch on it. Something else we'll touch on is salt. Of course, now definition of a salt. Of course, we'll define a salt. We have a reaction of salts, that is precipitation reaction, which we did again in Form 2. If you can remember, we were saying preparation of insoluble salts. One of the method was precipitation, where we form a white precipitate or any color precipitate, but of course now it is a solid. And then we have the solubility. We define what solubility is. We draw solubility curves. So hopefully, when we're doing these ones, I'll really be interested in you drawing graphs. Drawing graphs here are very important. Solubility curve actually is graphs, basically. So we will talk about that one, but from the name, curves. So we'll talk about curves. So it is solubility curve. And then we go to the applications of solubility curves. So we have what are the applications? What is it used for? That is actually what is the importance of these curves? So here tutaguzia pia. And then the last thing in this topic actually is hardness. Water hardness, the ions that are present in that makes water hardness, the types of hardness, and the methods of removing water hardness. I think last year you had one. I think it was tested. One of these one was tested actually. So it is very important for us to be very keen in this topic. Now, I hope that is okay. That one was just a brief introduction. I don't know if they've shared the KLB, the 44 KLB. I don't know, I'll check if I have mine. Mine, I think I summarized uh, some of it a bit. So I'll check if I have mine in soft copy, and then I can share. Then we can just start. So, like we said previously, previously I said an acid is a substance that dissociates in water to produce hydrogen ions as the only positively charged ions. So we are just maintaining that definition. We are not changing that one. So we just maintain this one as a substance that dissolves in water. It is okay to say it dissolves in water. Somebody else will say it is a substance that dissociates in water to produce hydrogen ions as the only positively charged ion, or the only positive ion. Now, the last time, again, I had given you another name for positively charged ions. So if somebody else, if you sometimes you forget to say, you can use that one. So the positively charged ions, you can say an acid is a substance that dissolves in water to produce hydrogen ions as the only cation. So this one should be, so again, it can be called cation. I hope you're okay. I hope you understand the meaning of cations. Now we have ions. Yeah, so we have ions. We have ions, two types of ions. We have the anions and the cations. So somebody else can say an acid is a substance that dissolves in water to produce hydrogen ions as the only cation. So that one is okay. So again, you still have used coit. Both of you are okay. Anybody who says, if you say cation and if you say positively charged ions. So we can say now, actually, when you define an acid now, basically what we're saying, it dissolves in water. Now, the last time I told you, when you have a concentrated acid, or the acid that has not been diluted, that means you have not added water. Actually, the state symbol changes. So it is no longer, when it is concentrated, we don't use acid. We use, it is a liquid. But when you introduce water into it, now it will dissociate. So when we dissociate, now we rub out the liquid part, because now it is no longer a liquid of itself. So we rub and then it becomes just. So that one, when it dissociates to form an hydrogen ion, so it will produce an hydrogen ion as the only ions that are positive. We say that one is an acid. Now this one, this one is hydrochloric acid. We have sulfuric acid. Actually, I don't want to categorize this one, the one with CH3, which is normally, the CH3 is normally what we call the alkyl group. I think we'll talk about that one later on, which is normally represented as R. So that R is normally, this one actually is normally alkanoic. Let me just use alkanoic acid. So for the exam, we normally count the number of carbons. So for example, this one is 1, 2. So when there are 2 carbons, it is ethanoic. It is ethanoic acid. So, but this one is all acids actually dissociates to give hydrogen ion, which is here, and another negative one. So there's no problem. We don't even have to touch on the other side. The properties that we are interested in actually is the hydrogen in this case. When we be talking about organic chem, we'll be interested now. We'll not be interested on this side.
Teacher?
Yes.
I can't see the board now.
You can see the screen now?
I can see, but the topic only.
Oh, sorry. Let me stop sharing and then I share again.
I can see the pink circles that you are drawing.
Oh, sorry. Let me just do this. Let me stop sharing and then I share again. If that is okay.
Okay.
Yes. That is better now?
Yes, it is visible now.
Yeah. So should I start again? I don't know. Should I start, or because of course now there's no problem, because after to gender palette is just, yeah, we are defining an acid. But did you got what an acid is, huh?
Yes.
Yeah. So actually, an acid that dissolves in water to produce hydrogen ions are the only positively charged ions. That is what I mentioned. And I said positively charged ions actually are called cations. That is what I had written. Cations. They are called cations. Now, Something else that I had talked about is an acid actually is a liquid before it is added water. So when it is in its form of concentrated acid, or when it is in its form of high concentration, we say it is a liquid. That is what I also had mentioned. I know you got that one, but what I was saying is when it is concentrated acid now, before we add anything, before we add water and the rest, this one is not aqueous. The state is not aqueous. We are normally denoted by letter R, which is a liquid. Now, so the first one is normally, so because now we are talking about something that has dissociated in water or that has been diluted in water, the aqueous part comes in. That is why you see I wrote it is okay to dissociate this one. So it has dissociated to produce hydrogen ions as the only positive ions. If we had two ions that are positive, then this one no longer qualifies as an acid. We'll have another definition of that term. I think we'll see it somewhere else. Most probably, we normally go to what we call now the complex ions. When we have more than either one cation or more than one anion, more than one negatively charged ion or more than one positively charged ion. So the other one is sulfuric acid. Now, this one I was talking about this one when you said we are the problem. So the alkyl group. Now, remember, alkyls are formed when you minus one hydrogen from an alkane. Yeah, if you remove one hydrogen from an alkane, it qualifies as an alkyl group. I think that one will come to. It will be very well defined in organic 1 and 2, from 3 and 4. So this one is from the word alkyl. Of course, it will now becomes alkanoic acid. But these are now in our case because the number of hydrogens are 2. Not hydrogens, carbons. Because the number of carbons are 2, which is this and this. So we have number 1 and number 2 carbons. This one now becomes ethanoic acid. So those ones are very weak acids. Actually, we'll be talking about those weak acids and strong acids. But because it dissociates to give us an hydrogen ion as the only positive ions, we do not care whether it is strong or weak, but we only say it is dissociating in water. Actually, it dissociates in water to release hydrogen ions as the only. And then we have, of course, another is the nitric acid. I hope that one is fine. But now, alkanoic acids, we'll talk about it later on. I'm very sure we'll talk about that one later on. So we have the strength of acids. So we can continue. Strength of acids. So we have strong acids and weak acids. Now, I want to talk something before even we go to this one because I know it will bring confusion. There is a strong acid and there is a weak acid, and then we have a concentrated acid and a dilute acid. So it is very important to fika hapo kwanza. You have a strong acid. Actually, most of the dilute acids a dilute acid is a strong acid. So I think normally brings out confusion. Strength of acid normally depend with the dissociations. It normally depends with the dissociation in water. But when you talk about concentration of an acid, we are talking mostly about the hydrogen ions that are present actually in the acid. So strength and concentration actually it normally brings confusion, but it is something very easy. So we can just strong acids actually as acids that I said the other time I told you dissociation and ionization is the same thing. So it's something acids that dissociates or ionize fully or completely. So it will depend with how your English is coming out when you are writing the exam. But the good thing is most of the sciences we don't mark. I think the only science that we mark English language is bio. Bio is actually very important because you don't have to you don't have to misspell the medicine you're giving people or something. But most of us we give a benefit of doubt to say maybe it is the language or your language now, your mother tongue is affecting your answering, especially in physics, chemistry really, but we don't really mark. So these ones are anyway. So these ones are acids that dissociate fully in water to give or to produce hydrogen ions. Now, sometimes because of that hurry, or because you are in a hurry, 2 hours is very little. So you forget this one. Let me just circle many hydrogen ions. Now, if you forget that one, I will give you a benefit of doubt because of this one. This one normally takes care, most of the time, it takes care of the many hydrogen ions. So it takes care of the word many, because if it is fully, that means it will produce a lot, obviously. So sometimes students normally forget many in their definition, which is okay. I'm saying as long as now you factor in the word completely or fully in that case. So examples of these ones, HCl, which is hydrochloric acid, nitric acid, sulfuric acid, and phosphoric 5 acid. So those ones are some of the strong acids. That means they will fully dissociate. We'll see how to identify a strong and a weak acid, so we don't have to be worried about that one. And that one is actually, that's something that it was done in Form 2 again. We'll just talk about it. So it is something that fully or completely dissociates in water to yield or to produce many hydrogen ions. So that one is very important. You have the examples. So what normally happens, actually the equation that we did previously is the same thing that will happen here. So the hydrogen chloride, which is in our case now is normal hydrochloric, will dissociate to produce hydrogen ions and chlorine ions, but there are many. The hydrogen ions are many. I hope that one is okay. So we continue. Weak acids. So we say something about weak acids. So actually, weak acid is the opposite of strong acid. Strong acids. So these are acids which undergo partial dissociations. Now, if you forget the word partial dissociation or partial ionization, you can use only the opposite of completely or fully. You say these are acids which does not undergo full dissociation or does not undergo complete dissociation. If you forget the word partial, that is. So actually, it is acids that undergo partial dissociations in water. It undergo partial dissociation in water to yield or to produce. Yielding is production. So to produce few hydrogen ions. Now I'm going to combine these examples. So these examples, when they ask you with examples, you can use ethanoic acid, methanoic, because those actually are different acids. Now, but I want to combine this one in families. So we have the carbonic acid. So let me just, I'll be writing a few things. So we have the carbonic acids, this one. Actually is a different family. And this one is, carbonic acid is normally presented by this number 1. Now, ethanoic, let me use a different pen so that it becomes easy. So, which one? A blue one. Okay, blue. So we have E, and this one, which is ethanoic and methanoic. The two of them belong to a family called alkanoic. So hizi mbili zinaitwa alkanoic acids. I'm just giving ni kama ile yenye nilikuwa nasema huko juu. So it is called alkanoic. But the good thing is we'll be mentioning it somewhere else. So you should not be worried if you don't, maybe you are not really quite familiar. So these ones are called alkanoic acids. Alkanoic acids. They are called alkanoic acids. Ethanoic and methanoic are called alkanoic acids. And they have what we call the alkyl group, which I had mentioned that it is the alkane part of it when you minus 1 hydrogen. So this one is alkyl group. But these ones you don't have to be worried as of now. So these ones normally undergoes partial ionization or dissociation to produce very few of these and few of hydrogen ions. And those ones now are considered as weak acids. So alkanoic acids and carbonic acids are a family of weak acids. In fact, carbonic acid we'll be talking about it somewhere in the food family. I think it is normally found in the food family. Kwa chakula, some of the food that we check, carbonic acids will be there. So they are weak acids. That is why it is not poisonous to use a weak acid. Actually, you can take a weak acid without having any effect. But a strong acid now will bring about effects to the body or sickness and other things. I hope that one is okay. I hope you have understood the reason why I've combined the ethanoic and methanoic acids. That one I wanted only to give you, but I'm saying when you're giving an example, you can even say propanoic. There's no problem. You can say methanoic, ethanoic, propanoic, that way following the number of carbon. Because this one has one carbon. So because anyway, we are doing revision. So this one has one carbon. This one has two. So from so this one now becomes, so E is us under ethanoic. This one now qualifies as our ethanoic because it has two carbons. When it has one, it is called methanoic. When it has three, now we go to propane, so propanoic. 4 butane, butano, that way. But that one is a story for another day. But I just wanted to give that idea of how these ones are formed. Now we continue. So remember, I have said something about weak and strong acid. So how do we know that this one is a weak acid, this one is a strong acid? There is the best method, which is the easiest in the lab, actually, is normally using the pH scale. We normally use the pH scale, the color of maybe what do you call it? I'm forgetting the name. There's a name that is not coming very well. Okay, it will come. When it comes, I'll tell you. When you use the pH scale or when you use the pH itself, we know that that one actually is normally we normally use this one in Form 1. The first thing in Form 1, when you're talking about acids, you're using the pH. When you say 1 to 3, strong acids, weak acid, we go 4 to almost 6.5, 6.8 there. We say those are weak acids. So that one is pH scale. Yes, yeah, it has come. So the color of an acid using the universal indicator. Actually, when you add the universal indicator, the color difference will be shown on the pH scale very clearly. So we normally use a universal indicator. When you add a universal indicator, maybe 2 drops in an acid, and it is a strong acid, it will give a different color. Actually, it will give you the color ranges from 1 to 6 based on the strength of the acid. The stronger the acid, that means the color will go to 1 to 3. It's actually when you use the universal indicator, compare the actual color, yeah, an acid that has a pH of 1, an acid that has a pH of 6, ukiweka universal indicator, it will give you that. So number one, we normally use that one, and using the pH is normally the most effective and the easiest way. Yes, I hope that one is okay. Number 2 is actually we use the rate of evolution of hydrogen gas. Remember, when we are defining the strong acids and the weak acids, we were talking about the yield of production of hydrogen ions. We are saying the other one produces more hydrogen, the other one produces fewer. So the more hydrogen gas, of course, that is formed because of the hydrogen ions. That one we say now the gas, not the gas, the acid is, the acid is strong. If it produces 10 liters of hydrogen, and the other one is producing 5 liters of hydrogen, we'll be saying yenye produce 10, yenye produce 5. The one that is producing 10 is a stronger acid. The one that produces 5 is a weaker acid. So, and of course, the rate of production in stronger acids is faster than that one. I was telling my students, I think this one could have been another factor. Could have been the amount that is produced. I was saying the amount that it could produce. I don't know. I thought it could be another factor, but that one is for another day. So the faster one that produces, now the one that produces many is a strong acid. and the rate of its production is higher. Yeah. So that is why I was saying I had always thought maybe this one could have been two factors, two in one. That means they're saying rate means faster, amount something different, because we talked about more. So so this one because of computer ionization, so the rate becomes higher. I have that factor. Have you understood that factor? Because may explain marambili. I have explained using the rate of production, that is them, and I've also talked about the amount. Umelewa, I hope you're okay, Mauro. Now it is very easy to teach you because you are only one. You tell me kama imekataa pale.
Yeah, just sijaelewa.
Yeah. So let me explain now using very easy terms. I think we use a lot of English. I don't normally like teaching chemistry with a lot of English, especially explaining of terms. We normally use very easy examples. So actually, let me just use what I wrote. So metals react with diluted acids. We know that when metals, that is what we did in Form 1. In fact, one of the preparation of hydrogen in Form 1 in water and hydrogen was reacting dilute acid with a metal. Hapo iko sawa?
Yeah.
Yes. So we produced, when we want to prepare hydrogen in Form 1, we said we are reacting a metal and a dilute acid. That one was very important. First of all, we were using dilute acids. We didn't use concentrated because most of the concentrated acids actually will react violently with metal. Now, so when we did that one, so the hydrogen gas are produced because of the hydrogen ions. So the hydrogen ions zinaungana pamoja. Hydrogen 1 and hydrogen 2, when they combine, they form what? They form hydrogen gas. And it is because the hydrogen has been displaced by the metal. So it is normally displacement of metals and then it takes part. That is how a salt is normally formed. Actually, this one is how a salt is formed. Now, so when you introduce a strong acid, now the reason why we normally say when you react a metal with, so instead of using this one, let me just explain using, so instead of if you remove this one and you use now, instead of using dilute, you use concentrated acid, we normally say the reaction is explosive. Are you aware of that? First of all,
Yeah.
are you
Yes.
aware of? Yes, so the reaction will be explosive. What normally brings out the explosion? What do you think brings out the explosion? Tukumbushane, what do you think brings out the explosion?
Because of the reaction between the conch and the metal.
Yeah, that is the reason. But I wanted the chemistry reason. Now I want you to remember. Let me just wacha tukumbushane kidogo. I want you to remember, how do we test hydrogen gas? What is the test for hydrogen gas? Let us just have a communication because we are the only in class. We are the only ones in class, so we can talk. How do we test for hydrogen gas? What is the test for hydrogen gas in chem? For example,
it produces a pop sound.
Yes. Now, pop sound. Now, the reason why we say metals react with concentrated acid and it becomes explosive. Now, when you bring a lot of hydrogen together and then you are reacting, we are causing with something hot, which at that times the reaction between a metal and the acid will produce some hot things. So because of that hot thing, it will tend to burn hydrogen. And hydrogen burns with a pop sound. So the explosion actually is because of that popping sound. So it will bring explosion. And hydrogen burns explosively. So we already know that one from test for. So that is actually why that one is never done, because of the hydrogen. Actually, it is because of the testing of hydrogen. I hope iko sawa. So strong acids will produce more hydrogens quickly such that now we don't do that because of that explosion that will occur. So strong acid normally produces more hydrogens very quickly. That is what we said about strong acid. That is actually the definition of acid. So it will produce more hydrogen, but the rate at which it produces, speed inaitoa ni haraka. I don't know if it is making, I don't know, Kiswahili I normally think is tougher than English. I don't know if you have the same sentiments, but I normally consider Kiswahili ni ngumu juu ya kutanisha maneno. You do something, you repeat yourself. So strong acids produces more hydrogen, and the speed at which it produces is higher than a weak acid. Hapo imekuwa heri. Is that one better? And this one is due to complete ionization and incomplete ionization. Sijui kama iko sawa?
Iko sawa.
Imekuwa better, yeah? But if there's a problem, it is better to say. And the good thing is that they're the only ones in class. So most of the time I could ask a question previous, your previous understanding of something. So I hope you don't mind that. Yeah. So we continue. So we have, so number one, we are saying you're using pH. So the pH one is the one that we are used to in the lab. I know even you are aware of that one because you have been using that one ever since. Now, using the rate of evolution of hydrogen is something that we don't normally use mostly in our classes or in our 844 system. 8.4 itself, that is from, yeah, okay. So that is from I don't know, we normally, I don't remember my primary, but I know we used from primary, I think we used that one in primary in science, and also we are using it now up to Form 4. When you'll be in campus, that one will be another alternative. It is something you use kama hizi zingine hazifanye, but most of the time we use the evolution of hydrogen. I think it is because of the tech they have and the availability of equipment. So in high school, the only thing we have is maybe the pH scale. So that is another problem. Now, method number three is the electrical conductivity. Electrical conductivity. Now, when you talk about the electrical conductivity, actually, we are talking about the ions that are produced to complete the circuit. Let me repeat that one very slowly. The effect of electric current on substances. That is in Form 2. You remember that topic? Have you ever had that topic? Effects of electric current on substances. So the one that we're using ions to migrate to the cathode, and the other one coming to the anode. Each of it is anode and cathode. Actually, it is this one.
Is it electrolysis? Electrolysis.
Electrolysis. Actually, you are better than me. Now that is good. Electrolysis. That one. So we are using electrolysis. So you can even say that one is another. You can use this one using electrical conductivity or using electrolysis. Actually, you are okay, very okay. So that one is I think that one is a point on you. So because strong acids fully dissociate, it will produce more hydrogen ions. Now, the weak acid will partially dissociate, so it produce fewer ions. How many fewer ions? We can say now the bulb, strong acid in a light brighter than let me just use those simple terms. So bulb, strong acid will light brighter than weak acid, because of few ions. So haitakuwa inachukua all the current. Full current will not be seen. I don't know if you are taking physics. I don't know if you are taking. Are you taking physics, Mauro?
No.
Okay. There's no problem. So full ionization means more iron. Partial ionization, few ions. So actually, good conductivity, strong. Poor conductivity, weak. Better that way? Is it okay that way? Yes.
Yeah.
So those are the major three ways of knowing whether it is a strong or a weak acid. But I'm saying the main one that we normally use is actually using the pH. which you normally use what you call the pH scale, which gives the strength of the acids, the strength of the bases together on that scale. Is normally actually summarizes as from pH 1 to pH 14. The others now are alternatives if you do not have, especially if you are missing what we call the universal indicator. So you will use the other, and then you can say now this solution A is a strong acid, solution B is a weak acid, or the vice versa, which is okay. Now, there was something that we spoke about. First of all, we said a strong acid and a weak acid. Now, there is a difference between concentrated acids and dilute acids. And I will not confuse you. I'll only use very simple terms. High number of acid molecules. What is the acid molecules? Actually, what uniambie sasa hiyo. What is the acid molecule? Acid molecules ni nini?
Hiyo sijui.
Okay. Now I want us to go to tutajifunza. Is it okay if I move too slowly? Will it really affect us? Yeah. So okay. So because I want to go something. I want to go somewhere fast. Let me cancel this before. So I want you to remember this definition, acid molecule. Now I want to go. Tunarudi juu kidogo. I hope you're still seeing the screen.
Yes.
Yes. So an acid is a substance that dissolves in water to produce what? Produce nini? Hydrogen ions. Yeah? Yes. And that one, the hydrogen ions, this H positive, is actually ions. These ones are acid molecules. An acid actually, when we be dealing with writing of equations, you will find that when I say acidified potassium manganate, I don't know if you saw something like that. Acidified potassium manganate 7, acidified water, any other water. We know. Sorry. So we normally say we denote. It is normally denoted by letter what?
H plus.
Positive.
Plus.
Yeah. Yes, that one now is the acid molecules. Because our. So anytime somebody asks you acid molecules, hydrogen ions. Of course, it must be ions. H positive. It is very important to. So I wanted only us to see that. So when you are down here, so an acid is an acid. So when you talk about concentrated acid, we are saying it is an acid. It is an acid with high number of acid molecule or high number. I'll use a very easy example for this one. I normally use an example of sugar. Adding sugar to tea. I'll use that example. So it has a high number of acid molecules, which I'm saying it has a high number of hydrogen ions. So hydrogen ions mean per given volume. For example, they'll tell you 10 liters. We have 10 liters. Ingine iko na hydrogens 1000 na ingine iko na hydrogens 100. So yenye iko na fewer, we say that one is a dilute one. Now, I want you to differentiate between a concentrated acid and a strong acid. The other one, there is full dissociation. Actually, this one we are only saying it is something that has iko na more sugar molecules in that tea. So umeweka sukari, for example, 5 teaspoons kwa kikombe. That we say now that one is concentrated sugar solution or concentrated tea with sugar. But there's some, if it is a strong acid, I'm talking now about the same kikombe you umeweka sukari. Na weka sukari kikombe kijiko moja. And then we say that kijiko moja ina fully dissociate, it still become a strong acid hata kama ni kijiko ngapi? Moja. Ile ingine umeweka 5, but it is a weak acid. Umeweka 5 yenye ni weak. we'll say now that one is concentrated with sugar, but it is not strong. Is there a better way to define this?
Yes.
Yeah. So acid molecule, when they say acid molecules, we are talking actually about hydrogen ions. So when you talk about dilute acids, so with low number of acid molecules per given volume, of course, it is very important to give per given volume of a solvent. When you talk about solvent, we are talking about the liquid. When you talk about solute, we talk about solute is the solid. So it is very important. So it is only the difference. So I normally give out certain so the way I explained, I normally say chemistry sometimes could be confusing, but the good thing is to understand. Of course, concentrated now. Anytime we're talking about dilute, it is the number of hydrogen ions. When you talk about the strength, we are talking about ionization, how it ionizes or how it produces the acid molecules. So those ones are very, very important. Now, NB, let me just show you what I was explaining using that. I want you to see what I was talking about. So a dilute acid has strong acids compared to concentrated acid. It is very important for you to understand that dilute acids could have few acid molecules, but could fully ionize, while the other one could be just having a concentration, but there is no ionization. Actually, that will take place. And I've said when something is actually liquid, it doesn't ionize. Unakumbuka nikisema hiyo huko juu, nilisema when it is acid yenye concentrated, most of the concentrated acids actually are not strong acids. They are concentrated acids. That is why tunasemanga it is concentrated sulfuric acid. We don't say in the lab it is a strong acid. Ama mliaifunzwa hivyo kweli? Or we say concentrated nitric or concentrated hydrochloric. That's what we normally say. Iko sawa hapo Maura? Yeah, that is what we normally say. Because now that one does not ionize. In ionize is the one that we have added water. So we normally say dilute acids actually are strong acids than the concentrated acids. I hope that one is okay. Because now the other one can form ions. Actually, concentrated acids cannot form ions because they are liquid form. But now when you have diluted acid, that means you have added water, they can ionize now. And then now, so that is why we say which of the following is a strong acid. Now, the question is saying which of the following is a strong acid between 0.5 molar HCl and 5 molar HCl, hydrochloric acid. So 0.5 is a strong acid. Iko sawa? The question can still be asked this way: which of the following is a concentrated acid? So which one is a concentrated acid between the two, 0.5 or 5?
5M.
Yeah, so 5M, yes, 5M is concentrated, 0.5 is strong. I hope that one is okay. Yes? Yeah, that one I think tumeelewa vizuri. Now, this topic is normally very confusing. Now, that is why I don't normally want to give students what you call the role of solvents on acid properties of a solution. Actually, I normally cancel that one out. I normally introduce this topic this way. Effect of a solvent on a solute. Effect of a solvent on a solute. I normally say that one. Effect of a solvent on a solute because it is actually told somewhere. Now, this question normally goes this way in an exam. HCl in water have an effect on have an effect on a litmus paper, but HCl in methyl benzene does not affect the litmus paper. Explain. Actually, that is I am very sure this question could be there in last year's exam. I've not just gotten the paper. Somebody sent me the paper yesterday. I have not had time to go through, but I think I'll go through it another time. Then I see. But this question normally comes in. So hydrogen chloride gas in water. This one again will be done in Form 3. So This one actually is done several, around, I don't know, three to four times before you sit for your exam. At least from Form 1 to Form 4, I think it is done almost three times or four times. So actually we normally say when we have water, normally is polar. That is, it has polarities. So when you add water into HCl, it will dissolve and it can ionize. So when it dissolves, it ionizes. So you remember your ionization. When it ionizes, it produces hydrogen ions and chloride ions. The hydrogen ions now are responsible for the acidic properties, or they make this thing now affect the litmus paper. Yes. And something else we can say is, if you the first one, let me just write for the sake of so that it makes sense. So when you talk about this one, we are talking about the color of litmus paper being affected. So in a litmus, so you will talk about litmus paper. And I've not given the actual litmus paper. We have two litmus papers. We have the blue and the red. So you'll tell me which one is affected by an acid. And this one now is the one that is responsible for the color change of that litmus paper. Something else I'm supposed to tell you about litmus paper. A litmus paper, ukipewa litmus paper kwa lab, when you're given a litmus paper in the lab, and you are tasting a gas, any gas, for example, maybe you're burning something, and they tell you to test the litmus paper to test the gas using the litmus paper. It is very important to know that for litmus paper to work, lazima we wet. I don't know, you're supposed to add water. You're aware of that. So that one is very essential to remember. So never forget. I've seen some of the students when you're doing the practical, wanasahau kuweka maji. I think it is maybe because of the tension or maybe because of time. So anasahau kuweka maji. So it is very important to know that lazima litmus paper uweke, lazima iwekwe maji, lazima iwekwe maji. Very important. Now, so that presence of hydrogen ion makes the water acidic. That's affecting the litmus paper. Is it the red one or the blue one? Think about that one. So red or the blue one is affected by the acid. So now, the resulting solution conducts electricity. So when they tell you, when they are now, the question can go this way. So nimesema affecting litmus paper is the first one. When you talk about electricity, we are talking about the bulb will light when you use water. While when you use methyl benzene, the bulb will not light. It is the same thing. This one is because now this one will dissociate to produce hydrogen ions and chloride ions, which are mobile. And we know that for conductivity to occur, we must have either free electrons or what we call the mobile ions. So it is either mobile electrons or mobile ions. So because this one has free mobile ions, it will conduct. Now, when you talk about liquids, they normally ask this one this way. They could even ask you to, this one could be what we call the electrolyte. Yeah, the one that you are talking about in electrolysis. So when you have the electrolyte, they will say when you use HCl gas in water, it becomes an electrolyte. While when you use HCl in methyl benzene, it does not. It doesn't qualify as, or it doesn't conduct electricity. It doesn't becomes an electrolyte. Explain. That one is very important. I hope unaelewa. Now we talk about solubility. We talk about the solubility of that thing, and then now we talk about litmus paper being affected and the current, electricity being transferred. And nimesema electricity ina require only two things actually. We normally say aluminium is a better conductor than sodium because of more free electrons. Aluminium iko na 3, while sodium iko na 1. So the more the number of electrons that is in metals. When we go now to electrolyte, we do not talk anymore about electrons. We talk about ions, mobile ions. Iko sawa mpaka hapo? Now,
Yes.
yeah, so let us continue. So hydrogen, actually this one, again, it will affect the bases the same way. So hydrogen gas in methyl benzene, of course, methyl benzene is non-polar. We normally non-polar. Polar actually means, I don't know if you have an idea of what polar things are. Polar means it has polarities. That means polarities is either positive or negative. So when it is non-polar, and hydrogen gas actually, hydrogen chloride gas actually is polar. Because iko na hydrogen which is positive na chlorine which is positive. Water is partially positive, partially negative. I hope you remember. So the partial negative will be attracted to the partial positive. So is ikivurutana, I think I'll explain down there somewhere using let me just explain after this. Are you aware of that? What I just mentioned? We just explain kidogo.
Niexplainie tu teacher. Can you reduce that volume?
Sorry?
Naambia mtu mwingine reduce volume. Ni explainie tu.
Also, I can explain my polarities. Okay, no problem. Wacha tumaliza alafu, because now this one brings in. Now, so methyl benzene actually, first of all, it will dissolve. Methyl benzene is a liquid, so it will dissolve the acids. The gas will dissolve first of all. But what happens is it will dissolve but not dissociate. So it will not dissociate. So upper. So it will not form the hydrogen ions and the chloride ions. But actually it will dissolve. It is very important to say it will dissolve. Because sometimes students will say it will not dissolve, which is wrong. Actually, it is wrong. It dissolves. But what happens is it does not dissociate. So hydrogen will exist as a molecule. It does not produce now the hydrogen ions, which will affect the litmus paper, and also the chloride ions, which will be the mobile ions. Let me just explain it that way. So the result is that because there is no dissociation, that means there is no production of hydrogen ions, and there is no production of chlorine ions. It will not affect the litmus paper, and also it will not conduct electricity because there is no mobile ion. Iko sawa hapo? It is very important also to understand that methyl benzene actually will dissolve hydrogen chloride. What happens is in a dissolve lakini I dissociate. There's a difference between actually dissolving something but not dissociating that thing. Yes. Let me now explain something on polar. I want to move it so that I have nafasi ya kutosha. I will explain using, so I hope you have understood your methyl benzene, and this one will be repeated. So you don't have to be worried. It will be repeated twice, actually. This one is the first time. There's another time I'll repeat it in Form 4. And then another time will be repeated in Form 3, which is normally chlorine and its compound. It is still repeated in that class. So, now let me explain something about polarity of water. When you say water is polar, we normally say water actually has is. Now let me just write for you. What is the chemical formula of water? Just shouting. You don't have to write it. What is the chemical formula for water?
H2O.
Yes. So it is H2O. Now remember, the oxide of what we mean is this one, oxygen normally, sorry, I'm not so, yeah, oxygen normally attracts two hydrogen. So this one is what is happening. Now, what you're supposed to know, let me write it okay correctly. So hydrogen is positively charged. Na hii pia ni positively charged. Let me write it a little bit further. And then this one is 2 negative. Siko sawa? So we normally say it is partial positive. So we normally do it something like confuse D. Partial positive and partially negative. Now, hydrogen chloride normally looks like this. So we have hydrogen positive also, and then it has chloride which is negative. So something that is polar. So this one now, Polar means it has a negative, it has polarities. You know, polarity is positive and negative. So it will have negative and positive. Hata hii pia huku ni polar. You're gonna positive and negative. So the positive of this one will be attracted by ule huyu wa huku. And this one will be attracted on this other side by the two now. So when that one happens, that means we are co-joining. So we join together. And when you join together now, there will be movement. There will be movement. We'll be having now hydrogen ions zinatembea peke yake ziko pia. Yeah. We also be having chloride ion moving. So when that one happens now, so I'm going here, and remember it is a two-way process. So our pia wanataka kuenda the other side because tumekutanishwa, mumewekwa room moja, so everybody wants to go to the other side. So because of that now we say now there will be mobile ions. Si hapo hapa hata wewe unaona kuna movement. So because of mobile ions there is conduction of electricity. And then because now some of the ions that are moving are hydrogen ions, which brings out the acidic property. Inapita hivi inaguza litmus paper. And because they are dominant, of course, hydrogen ions, we know they are dominant. Acidic properties are dominant. And of course, basic properties are dominant in a solution. So because they are dominant, wao ndo kusema hiyo time. So litmus paper ikipita hivi inabadilishwa color. Tuko sawa mpaka hapo? That is polar substances. Umeelewa kitu Mwaura? Because next time they will ask you what is the understanding of polar substance. If not, it is better to repeat because we are the two of us. So it is very easy to. But if we are okay, we continue. Yeah. So we continue now. So we have the comparison of properties of solution, hydrogen gas in water and methyl benzene. So actually, in methyl benzene, there will be no effervescence when you had a metal, any metal in that case, there will be no effervescence. When you had HCl in water, there will be effervescence with production of a gas, which burns with a pop sound. That one is the preparation of hydrogen. That is in form 1. When we had sodium carbonate, because these are the things that are normally done in the lab. Isn't it vitu tunafanyanga? You remember you had sodium carbonate. You will find that there is no effervescence when it is in methyl benzene, but effervescence, and then we produce a gas that forms a white precipitate with lime water. This one is lime water, calcium hydroxide solution. I don't know which gas. But hey, let us just think about which gas do you think form a white precipitate with calcium oxide? Unaweza jua?
Calcium oxide.
Yeah, calcium hydroxide. Which gas actually forms a white precipitate with calcium hydroxide solution?
CO2.
Yeah, so you are okay. Just you are good. Tunapitia tu. So that one actually is in form 2. So actually you are very good. So these ones are things that we normally use in the lab. So when you do that now, the inference, I don't know, you normally say inference. At the end, you say now carbonate ions, CO32 negative, comma, SO, because calcium sulfate also is insoluble. So SO4, 2 negative ions present. So that one we could have, you can add, okay. Kumbe ndio hii. So I wanted to say you can add sodium sulfate or sulfite. The addition of sodium sulfite, we have no effervescence in the other one. So effervescence of a colorless gas that changes filter paper soaked in acidified. So they normally say you can check the filter paper. If it is soaked in acidified, how is it affected? That is another alternative. But we normally use litmus paper mara mingi. This one, the reason why I brought in this one is so that you understand that the dichromate normally changes from orange to green in acidic gases. For example, acidic gases include chlorine, the carbon. Actually, carbon is normally neutral gas, but its properties in water brings out the acidic property parts. Sulfur 4 oxide, sulfur 6 oxide, those ones. So test with dry blue litmus paper. This one, that's why I was asking, which litmus paper do we use? Is it the blue or the red? So, I think we'll talk about the red when we're talking about the bases. So we have no effect on the blue litmus paper when it is in methyl benzene. So to look at my effect litmus paper, you? Now the blue litmus paper changes to red when it is in water. There's something else I want to say about this. Now, sometimes in the lab, I don't know. I think teachers we are very tricky sometimes. So what I normally do in the lab, for example, I give out an exam and then I give you 2 litmus paper. I give you the blue one and the red one. And you're supposed to use both of them up a kute. And then you only write the blue litmus paper is affected and it changes to red. And then you don't tell me anything about red. You assume that. So anytime you're given the blue litmus and the red litmus, and one of them changes and the other one does not change, it is very good to, or it is very okay. In fact, you would be right if you say the red litmus paper is not affected. And then now you explain the blue changing to red. Sijui kama umeshika hapo, nataka ushike hapo kabisa. In fact, for practical purposes, shika hiyo.
Hiyo nimeshika.
Shika hiyo. So wakikupea zote litmus paper na waje specify kwa question ya kwamba utumie either the blue or the red one. So in short, they're saying use both of them. You account for the both of them that you are given. You account for both blue and the red. You say blue is affected or it changes to red, and then the red remains unchanged or the red remains red. That's why I'm saying we don't really, it doesn't really, English is not really affected a lot, because if you say red remains red, actually in English it is wrong. So red remains unchanged. That one is very important. Addition of so this one is actually what we normally do in the lab. This one is a practical. These ones are practical sessions. But because I thought because this one, because it is actually we are doing practical at the same time we are doing theory. I thought maybe I can add something, but this one can be done actually in the lab. So when we have addition of copper 2 oxide, say copper 2 oxide does not dissolve. The other one, copper 2 oxide dissolves actually to form, depending on what is there, most probably it could form a blue solution because of the copper ions, or it could form a green solution because of a complex ion. Other one is okay, but mara mingi inaweza form nini? A blue solution, not green. Mara mingi ina form blue. Addition of solid potassium manganate 7, no change. Evolution of pale green gas. Pale green gas actually is chlorine, so you love chlorine. This one is an equation that we will write. We will write reaction between potassium manganate 7 and HCl. And one of the evolution, actually the pale green gas, wacha tu nikuandikie, pale green gas, which is actually poisonous, is chlorine. So chlorine gas is that one. Iko sawa? Now, the reason we are talking about this green solution is you're talking because of chlorine. Tuko sawa? But it becomes dominant over the Cu positive. Becomes dominant over the Cu positive, which is actually the copper ions, which are normally blue. I hope that one is okay, so that I go to bases. Yes. So bases. So actually we are done with the acids. So acids, we need to know the definition. You are supposed to know examples, the differences, how to know the strength of an acid, definition of concentrated acid, and how to identify the concentration of acids. So bases actually is a substance that is used in water to produce hydroxide ions as the only are negatively charged ions. Now, let me say something about hydroxide ions. Anytime you see hydroxide, there's no problem. If somebody else wrote hydroxyl, somebody will use another name, hydroxyl. I think you have ever heard me using it, Maraming. Hydroxyl ions and hydroxyl. So let me use this one. Hydroxyl. I had a Y here and a L. So hydroxide and hydroxyl. Hydroxide ions actually is hydroxyl ions are the only negatively charged ions. So when I said the other time that dissociations actually means it is dissociation, actually this word and these words, dissociation and ionization are the same thing. So when it dissociates, the other ions that are produced are cations. So these one now are anions. So it dissociates. You can even write in an exam. You know, sometimes we forget. Unaweza kuwa unaharakisha and then you realize kumbe sikuandika negatively charged ions. So negatively charged ions are anions. So you can say somebody, there's a student from my school who normally call these ones anions. Then I asked him, why do you call anions anions? I don't know. I don't know how you call them also. So alikuwa nilimuuliza, why do you call it that way? Akasema, it is because I will not forget. So it is onions. I don't know, he was using onions. Akasema, when I use examples of food, I never forget. So I don't know. So hydroxyl, it produces anions, which is telling me anions, and it is good, he never forgets. So it produces anions. Anions takes care of the negatively charged ions. So ukishaandika produces hydroxide anions, I will know that anions are negatively charged ions. But if you know that it may be uko sawa, you write the full thing. It produces hydroxide ions as the only negative charge ions. Now, if you are during the definition of that term, if you have to define, let me wrap this on first. If you during the definition, you get a little bit confused. You don't know if it is you are talking about what hydroxide. You can write this one OH negative, but remember to follow the rules of writing chemical formulas of substances of elements and the rest. That one you don't auandiki capital pali inapaswa kuwa small and small where there should be a capital, and of course they should not touch. Now, so when you do that from the definition, it dissociates to form hydroxide ion. So this one, the OH becomes dominant than the positive one. So that way. So now in Form 1, I hope you up sawa. I didn't want to do a lot of things there. So in Form 1, we say a base is a host that reacts with acid to produce salt and water only. That is actually how we define the base. Acid, we say, is a substance that reacts with bases to produce salt and water only. I remember that was the definition that we used that time. Now we don't use that definition anymore. We are saying we are talking about dissociations to produce the molecules of the acids or the molecules of the bases. So actually, pale tutafika nikuulize molecules of bases. You can easily say it is an hydroxyl or hydroxide or the OH group, OH negative. Tuko sawa, sindio? So now, something else that people normally confuse. We normally confuse manena alkali, because sometimes you hear me saying alkali solution, and then I will talk about basic solution, especially in the lab. We normally talk about all of those ones at the same time. I don't know if you ever heard of hizo vitu yenye watu wanasema alkaline solution basic solution. Ever heard of those things being said in the lab? So that sometimes students will be saying, why did you say alkaline here alafu ukasema base up or basic solution hapa? So actually an alkaline solution, when you dissolve a base, it will form an alkaline solution or an alkali or a basic solution, because actually it has basic properties. So there's no difference between an alkaline solution, a basic solution, because all of them actually we are talking about the OH group being in that thing or being in that solution. We are talking about OH group being in that solution. So we are going again to talk about the strength of acids, but before we do that one, so when you react, this one is a base plus an acid, it will form a salt and water. What do you think is the name of that equation? What is the name of that equation? I've mentioned it several times, not today, but I think I've mentioned it in one of our classes.
Neutralization reaction.
Yeah, that one is a neutralization reaction. Na ninasemanga kama kuna equation yenye ni rahisi kubalance na kuandika, I still repeat that one. It is a neutralization reaction. It is the easiest equation to write and to balance. The only time that it could be tough is maybe when you're using carbonic acids and is it carbonic acids and the alkanoic acids. Otherwise, when it is those regular acids that we use in the lab, imagine you're good to go. It becomes very easy. Now, I hope that one is okay. I just wanted to go through. So when you react a base and an acid, it only exists the formation of a salt and water. Now, the salt of water, we normally, I think we wrote that one in form, the other class. When we were in form 2, I think I showed how the ions are being exchanged. One of them, so the metal will let me just explain for the sake very quickly. I think that one will be very easy. So this one, for example, and this one. So huyu anakuja hapa na akifika hapo anamwambia hydrogen, please excuse me, I'm more reactive than you, please leave. Hydrogen will be very humble and then will say it is okay because I can't fight you because you're stronger than me. You take over. And then it takes over now the sulfate ions. And then because now the hydrogen was displaced, it will look for, yes? Somebody was saying something.
Not me, maybe somebody else.
No, I've muted, there's somebody who was in, but I didn't mute, so it is okay. I think I've muted them. So actually what happens now is the sodium or the metal will come in and then it will kick out the hydrogen. Now, because the hydrogen is lonely, it can't stay alone. It's very unstable when it is alone. It will also say, who is there? Nani ako hapo? And you see the hydroxide also is very unstable. So because two people who are very unstable wanatembea tu kwa barabara, most probably they will take each other. That is where now the water comes in. The hydrogen, very unstable. Hydrogen ions actually. They are hydrogen ions, by the way. And the hydroxyl ions also very unstable. So zinagongana, zinakutana, they form water, which is now a better or a more stable option. Of course, water is stable. Tuko sawa mpaka hapo? Now, so that we continue now. Now we go to the strength of the bases or the strength of the alkali. Now, when you talk about strength of bases, it is the same thing. Strong bases are those that undergo full or complete dissociations to yield more hydroxyl. Now, this one is where your word sasa imekuja. I normally write it differently in other places so that students cannot forget that hydroxyl and hydroxide ions are the same. So upper bases that are go complete. This one is very important when you're doing definition of that strong. Or you say, if you forget complete, you say full dissociation. Full dissociation in aqueous solution to yield or to produce a high number of or more number of hydrogen ions. A very good example that what actually we use in the lab is normally sodium hydroxide and potassium hydroxide. Those ones are the best that we use, and they dissociate fully to produce now more hydrogen ions or hydroxyl ions and another ion. And the hydroxyl ions are the only negative ions in that position. Now, the only negative ions, and they are more dominant than the positive ions. We'll talk about that when we are defining using the Brosted. I wanted actually to figure out a Brosted definition so that you understand what I'm talking about. Now, weak acids, weak bases, weak alkalis, then I go partial dissociation. They undergo partial dissociation. So this one normally undergoes partial dissociation in aqueous solution. So nasema actually sodium hydroxide, when it is in liquid form, that means umemeltisha sodium hydroxide. That means umemeltisha sodium hydroxide. Don't know who this is. Let me pick this call. Maybe it could be a student, or I don't know if it is a student. Otherwise, just a few minutes.
Domitila, sasa
Yes.
ukoaje?
Poa sana.
Okay, nimejoin kinda late, but I'm trying to catch up.
Mhm.
Mm.
Dada huku.
Marietta, I don't know if your name is Marietta. I know you came late. Now, I'd requested madam to look for the student. Akaniambia
Yeah, it's
niendeleaje.
okay. It's okay, it's
Okay, but
okay.
the good thing it is being recorded, so it can be played later on. So you can
Yeah,
go to
niko
a
sawa
replay.
mwalimu, don't worry. Niko sawa.
Yeah, and then I'll still share the notes on the wall and maybe some questions. Because our
Yeah,
yeah,
niko sawa. Thank you.
yeah. So actually, the person who called, I thought it was a student because I had shared my number on the wall. No, it is not somebody else. But I just cancel. I'm very sorry for about that. Now, so we normally say weak bases or weak alkaline solutions are those ones that undergo partial dissociation in aqueous solution, yielding to very few hydroxyl ions. Few means now. I want you to remember, Manena, when you're talking about the strong acids and the concentrated acids, it is the same thing. So few number of hydroxyl ions or the few number of alkaline ions or alkaline molecules. That one. Very good examples. Now these are the good example. Now the very best example that I normally give actually is not even the calcium or the magnesium. Of course, magnesium hydroxide is the one that we normally use for what do you call it to stomach acidity. Unatumanga for unatumanga mtoto aende nini? What do you call hizo vitu the tablet za kumeza za tumbo anti-acid which I think Africans they did change the
Acetone.
name to yeah those ones. But we normally tell our children to go for I don't know if it affects you, but I'm a Kalenjin, so we were being told to go for antacid, antacid or something, antacid. But actually it was anti-acid. But now our parents, I don't know, they got it wrong. So it is actually all of those ones you have mentioned are called anti-acids, and all of them, if not most of them, if not all of them, actually contains this. Actually, all of them contains magnesium hydroxide. It is very good. Magnesium hydroxide is a very good antacid with no very low effect to the human body. So it normally contains. So that one is a weak acid. But the best one that we normally use because of the reason why I normally use that one, strong acids. I normally use sodium hydroxide. I normally use it mainly because I have my own reasons, which I'll give you down there. When I talk about weak acids, weak bases, sorry, why is acids? So when I talk about strong bases, I use sodium hydroxide. When I talk about weak bases or weak alkaline solutions, I always go with the ammonium hydroxide rather than the rest. And I have my own reason because this one is normally tested. Now we'll talk about those ones, apochin. I think it is almost the next thing that comes in. So we continue. Hapo tumeelewana? So a very good example, I normally say when you're dealing with definition of terms, when you please define a term, if it has examples. For example, the last time we were in class, I was talking about maybe talking of this type of salts. The types of salts, we are saying double salts, we have the acid salts, the basic salts, and the normal salts. Those ones, at least have an example. The same thing now happens with the definition that we are doing here. At least I have example because sometimes I could set a question and say, with an example, define or differentiate that way. So it is very important to now comparing the strength of acid. Now, how do we know the strength of acid, the strength of bases? Now, this one, the reason I'm doing, I'm getting a little bit going there and near is because when I teach, how I normally teach this one, I normally combine both of them such that I will say, because now, for example, comparing the strength of bases, using the pH values, it is the same. I'll say pH from 1 to 6 point something is acid, 7 is neutral. Now, above 7, that is 7.1, 7.3 kwenda juu to 14. Now, I normally say they are bases. The strength of bases is this. 14, very strong base. As you come nearer to the neutral point, it becomes a weak base. The same with acids. So that one is, this one actually is the main method of checking the strength of bases and acids. It is the main one that we use in our schools, in our labs. This one is the main one because it is the cheapest method. Actually, when you use, I normally tell people, when you use the universal indicator, it will give, when you use a universal indicator, it will give you the color, the actual color that you will see using the pH now scale. So utapata zimetoa green, zingine zinakuwa yellow, zingine zinakuwa brown. Now, brown could be pH of 11. You say now that one is a strong acid. Another one you'll get maybe orange, you get pH 8. You say now that one is a weak base. This is very important. That one is something. Now, the second method of knowing whether it is a strong or a weak base is normally the electrical conductivity. In electrical conductivity, we use the number of ions that are produced. Mobile ions. Electrical conductivity, the word mobile or free ions must be indicated. So, because strong bases normally, this is used completely, so it will produce more ions that are mobile and high electrical conductivity. Now, I will go to, I don't know, I don't think you have done this topic, but I think it will be done. I'll just give you an hint. When you'll be in Form 2, I think the periodic table, we'll be talking about the connectivity, where we'll say more electrons, more mobile electrons, that is in group 3, is a better conductor than group 2, which is also a better conductor than group 1, because of the number of electrons. The more the electrons, the more the electrons, the more the conductivity. That one is very important. So because this one completely dissociates to produce more mobile ions, it will be a better conductor than weak bases, which partially dissociates and fewer. Now, I was telling, I don't know if Marita was in, but when I was talking about this one, I was talking about, I told about the acids. I was saying, we normally use a bulb. In fact, we normally use a bulb. The normal bulb, zile za torch za kitambo, zenye zilikuwa zinakuja na, I don't know, something ya red hapo juu. We use those bulbs. Wachana na the LED. I don't know. The LED bulbs now is the new norm, but we use the normal bulbs. Zile za kitambo. If you use a stronger base or a stronger acid, it will light brighter than when you use a weak base. And that is how you would know. Or that is how you would know if it is strong or weak. Aha. Number three, there's a slight change here. Is using enthalpy of neutralization. I will not explain this one because it is in the next topic. After this, we have energy changes, and this one is where it will come in very well. But we just use this explanation this way because I know we'll be mixing things, but I know I will remember to mention it when we be in that topic. So strong bases normally have high enthalpy of neutralization because of full ionization. Neutralization actually comes from OH, so it is a better OH. It has better that's why wanasemanga, or if you have people normally say if you have an how do you call it? Acid reaction in your stomach, you take a base. So the OH group, of course, you don't take a stronger base because strong bases normally corrodes. For example, sodium hydroxide is corrosive. If you take by the way, concentrated sodium hydroxide, even 2 molar, it will be issues. It brings issues. So this one is very dangerous. So strong bases normally have enthalpy of neutralization, and we don't need a high enthalpy of neutralization because if you have an acid problem in the stomach, you don't take those things that have very high enthalpy of neutralization because it will produce heat. It reacts later more to equal hot, and that one will burn the stomach. So we only require those things that have good neutralization power, but not extreme. So because we are human beings, so strong bases have better neutralization. This one I'm saying it is because of the OH group, while weaker ones they have fewer or lower because they do not completely ionize. Hope that one is okay. But I'm saying these ones, the number third one especially, I don't normally explain it a lot because I'll do it again. But it is good to know. Actually, I normally teach the only two, using the pH and the electrical conductivity because they share. Enthalpy of neutralization, I normally skip it. And this one normally is enthalpy of neutralization is normally used. The example that I normally give is having a stomach ache because of acid, and then you take an anti-acid. So the enthalpy of neutralization should be actually the one that can be contained in the stomach without having now more complicated issues. I hope we are okay. Mpaka hapo. Now, concentrated and dilute bases. Concentrated and dilute bases are actually the definition of strong and dilute and concentrated and weak. Concentrated, dilute, strong, weak is the same in both the acids and the bases. So is a base solution with high number of base molecules. Sasa nilikuwa nimeuliza, what is the base molecules actually we are talking about here now? These molecules per given volume or per unit volume. So is a solution, base solution with high number of base molecules. Which one is the base molecules? Mwauru. Base molecules? Somebody tell me what base molecules are actually. Yeah. Marietta, do you have an idea what a base molecule is? Or
Uh,
just
No, mwalimu, I don't.
I don't know, Mauro was in, so I don't know. I think she can assist us. Base molecule.
Hydroxide ion.
Yeah, it is
Hydroxide ion.
hydroxide ion. So Marietta, I'll just help you. Let me just help you a little bit. See, it is okay, Mauro. We help Akidogo and then we continue because
Yeah,
it is very
yeah.
essential. Yeah. So, so when you talk about base molecules, we are talking about the OH group. Those how we represent a base. Now, a base actually, when I'm talking about a base, if I don't want to write the whole name, I just want to write to give somebody an idea that actually what they are seeing is a base. I normally write as OH negative. If I want, so those ones are base molecules that actually affect that reaction in any way. Now, if I want to give an acid actually, let me just acid normally is represented. So the acid molecule is normally H positive. So anytime you see an H positive, you don't even have to ask somebody what is this is. Or ukienda lab na uone imeandikwa acidified or they have put H positive potassium manganate 7, you say automatically you know that one is acidified. If they're not actually, if it is not written in the English term, which is acidified. So if they just put H positive, of course, in other reactions, we'll be saying you'll see sometimes when I'm writing the equation. For example, I'm writing A. Let me just do this one for understanding. A plus B, and then because I don't want to write in presence of an acid, I introduce something here. Utaona nimeandika there is a condition that is being met, which is H positive. So H positive to give us C plus D. Actually, what this means is we had a few molecules of an acid, or we had a few drops of hydrogen ions, and hydrogen ions are actually gotten from an acid. Hapo iko sawa. So when we talk of acid molecules, we are talking of H hydrogens, H positive or hydrogen ions. When you talk about bases, we are talking about the OH, or the hydroxyl or hydroxide ion. Marietta, I think that one is better now. You can continue. I just wanted you
Yes.
to get the difference. Yeah. Because so but actually this one is per given volume. So when you talk about dilute, we are saying it has a lower number of hydrogen, lower number of hydrogen, hydroxyl, not OH, hydroxide or hydroxyl. So it has a lower number of base molecules, which to say base molecules is OH. When you talk about the, and this one is wrong, of course, you should remember that when you're writing the equations, when you decide to write now the OH molecule, please, when you decide to write in an exam, instead of writing base molecule, you decide to write OH, make sure that you are writing the correct thing. OH is normally, you write O, and then you give a space, you write H, all of them are capital, and then you put a dash. Just show that it is negatively charged, a given volume. Now, I'll explain this one the same way. Just like acids, because we did acids, dilute bases are strong bases. I'll repeat this one again for Marietta's purpose. So, just like acids, dilute bases are strong bases than concentrated bases. This is because dilute bases have fewer base molecules than solvent molecules. Therefore, ionization will take place in actual solution than the concentrated ones, because the concentrated one actually is liquid. Na nimesema when you talk about liquid, when you talk about liquid, it does not ionize. Actually, liquid does not ionize. The one that ionizes is those ones that have what? water particles. Kidogo iko na maji. So because it has water, it will dissociate or it will be form ions. Let me say it will form ions. So concentrated bases have a large amount of OH in itself, but it does not dissociate. Now, the other one, the ions are few, but it dissociates. That is how we say it is stronger acid than rather than a weak acid. So I don't know. I had given another example of 0.5 molar sodium hydroxide and 10 molar sodium hydroxide. So 0.5 molar is a strong base. 10 molar is a concentrated base. I don't know if you are getting what I'm saying. I don't know if you're getting what I'm saying. Now it would have been easier if you know it is easy to explain in both directions. Now, role of solvents, I think this one could be the last thing, but I wanted something. I don't know. I don't know if this one will allow us. I wanted to give. It is okay. It is okay. There was another definition I wanted to give of base and acid, but I think I'll give that one before we end. Because we have a few minutes. We have around 10 to 15 minutes remaining. So you remember, Maura, there was a place where we were saying dissolving HCl in water and methyl benzene. Yeah. So we are having here now, what we're having here, we do the same thing, but now we bring in the base. So we add ammonia in water and also ammonia in methyl benzene. So ammonia in water. I'll use the same property. So solution ammonia is basic. So the actual ammonium hydroxide. So it is ammonia. When you bring ammonia gas and water, it forms ammonium hydroxide. The ammonium hydroxide dissociates in water to produce the OH because I just normally start with the OH because of so it produces the OH and ammonium ion. Now the hydroxide ion actually is the basic. It brings out the basic nature, or what you call the alkaline nature. Basic. It brings out the basic nature and changes the litmus paper. It changes the red to blue. So it actually affects the litmus paper. And the question normally comes this way. That is, I normally put the question when I'm discussing most of the time. Ammonia gas in water affects litmus paper. But in methyl benzene, it does not. Explain. Yes. Something else. They will tell you, they will use another question. Is ammonia in water has a better brightness or is bright than methyl benzene and the ammonia in methyl benzene? Explain. That one is actually we are using the conductivity. So because it undergoes dissociation in water, that means there will be ions that can move, so it will conduct electricity. But in methyl benzene, so we'll go to that one. So actually the solution is a weak base. So that one is okay. It undergoes partial dissociation. I think we had given that one as number one, actually as one of the first example in weak bases. We had given that one. And I said I normally choose this one for my own reasons. And I think that my own reasons is just below. We'll talk about that one as we continue. So ammonia in methyl benzene, we say it has no effect on. Number one, it has no effect on litmus paper, and it does not conduct. There will be no lighting on the bulb. So is neutral sin. So we bring out again the idea of polarities, non-polar and polar substances. So it will not dissociate to form ions, and if there are no ions, there will be no effect on the litmus paper. If there are no ions, there will be no lighting on the bulb. So the bulb will not light. Yeah. I hope that one is okay. Especially now, I'm worried about Marietta explaining this, but Maura, I'm very positive that you can explain this one now, especially using the polarities and the non-polar. Polarities using the non-polar and the polar substances. Actually, I think you can explain that one better. Yeah. So for solute to show acidic or basic properties, that one is a note that is very important. That is what I mentioned in acidic, but we didn't even, it was not noted down. Our basic properties are polar solvent, e.g., water, must be used. Now, if you don't use something that is polar, you will not actually get the correct basic or the acidic properties of substance. So it is very important to use those ones. Now, so ammonia and of course that one will exist as molecules. So if they exist as molecules in the other ones, that means they have not separated the ions. Of course, you know that ammonia is ammonium hydroxide, but when it is a molecule, it's still ammonia and hydroxide together. Okay, separate the two ions now. That is now where it can affect the litmus paper, and also it can affect the conductivity or lighting of that bulb. You come to mpaka hapo? Yes, I wanted this one. This one, I think I wanted this one to be my last definition. What do you call the Bronsted? This one is somebody's name actually. Bronsted Lowry definition. The Bronsted Lowry definition. I think this one. There was an exam that they gave out, the KCSE, which was last year's KCSE. It is not last year. It is the immediate before. They asked actually using the Bronsted Lowry definition. Define base in an acid. Actually, students gave the definition that we just gave. The other one where we say this is a substance that is used in water to produce. Now, an acid is a proton donor. A base is a proton acceptor. I'll repeat that one very few. Now, for the second, an acid is a proton donor. And then we can go to something else. And then we say a base is a proton acceptor. Now I want to write something. How do we normally how do we represent a base? No, how do we represent an acid? So represent acid aja? What is the representative of an acid? I just mentioned that one. How do we represent an acid? So that I explain in summary upper two before we go there. How do we represent an acid? Marietta, I think we had mentioned that one. How do we represent an acid? A representation of an acid. Somebody to give me so that I continue. We're just reminding ourselves anyway, because it's something that we already did. And we have few, so we can have a discussion in the class. Very easy. A representation of an acid.
H plus.
H plus, yeah. So H plus. A base. We're just giving so. Yes, OH negative. So tunakumbushana tu. I think when we do that one, we don't forget, especially that because we are not writing a lot of things. OH. Now, OH negative. Now, what is a proton? What is a proton? Is proton negative? Let me just ask in simpler. What is the charge of a proton? Now, I want you to remember electrons are negative, neutrons are neutral, protons now becomes positive. So actually, let me just put all of them that way because protons is a proton. So protons are positive. Now, what do you know about the law of charges? Law of charges. What do you know about the law of charges? What do you know about the law? What is the law of charges, first of all? Because I think it is mentioned in very many subjects. In high school, we mentioned law of charges a lot of times, a lot. Actually, me, I teach both subjects that have that law of charges. Oh, have you ever heard of what you call law of charges? Where we say like charges repel, while unlike attracts.
Attract.
Ever, yeah, you ever heard of those ones? Now, what do you see about the H in an acid in a proton and H in acid is actually H. Clear? Now, if the proton is positive and the acid is positive, will the two attract? Will the positive and the positive attract?
No, no, no.
No. So it will be, so that is why now we say it is a proton donor acid. I normally explain it this way because it is easier for people to remember that acid is H, so and proton is positive. So because it is positive and the positive, they will not attract eventually. So the other one, in fact, H is pushing away the proton. Now, the base is negative and the proton is positive. Will they attract? Yes, they will because of the law. So it is very easy to remember that the Bronsted-Lowry definition of an acid is the proton donor because both of them are positive, so it will actually chase the other one away. While a base is an acceptor because it is negative and something that is coming in is positive, so it will attract eventually. So is that okay? Instead of using a lot of terms, I normally explain it that way for easy understanding. It is easier that way, that because in the long run, what we're interested in is knowing that an acid is a proton donor and a base is a proton acceptor. Yeah. Somebody else will say acid is normally does the proton donation. It is the same thing. Actually, it is the same thing. Actually, manipulating the English, there's no problem. So, so actually, an acid normally donates the proton because it hydrogen. Actually, when you'll be in form two, I think it is what is the name now? The periodic table and its elements. We'll be talking about the number of electrons, the number of protons, and the number of um, neutrons, electrons, neutrons, and protons that an element has. Actually, each one. We'll talk about that one in hydrogen. So I don't want to talk about that one. Actually, because there is no electrons and there is no neutrons, hydrogen ions actually is positive because the electrons has been donated and the rest. So because of that now, I don't know. Yeah, okay. So because of that now, it only has a positive, so it will donate. But if it OH also does not have, see, it is OH and it is negative. So it doesn't have anything positive. And the proton actually is positive. So it will take the positive. Yeah. I don't know if somebody has a question, because that one is a very dangerous place. That one, especially Bronsted. Now, differentiate between the Bronsted-Lowry definition. Please don't forget that one. Don't forget to differentiate. And also don't forget to differentiate the two, that is the Bronsted-Lowry and the actual definition that we use. Where we are talking about the H positive and as a base, full ionization to produce those ones. Another one, full ionization to produce OH. Ionization to produce OH. And then you don't forget to differentiate that is proton donor, proton acceptor. Because sometimes they ask. I hope that one is okay. I hope that one is okay. Now, this one is an example that will be done. Now, the example that is just here is an example again that will be done. We will do it again in another. We do it actually, I think 2 times. We'll do it in the next topic, and also we are doing it here. So in the forward direction, so we normally do forward and backward reaction, equilibrium reactions. I think that one is the rest of reaction. I think that is the next topic. If not, it is the third topic, but I think it will be there in form 4. So the water gains a proton to form hydroxonium. Actually, this one is called hydroxonium ion. I think you'll be doing when we'll be doing using dot and X diagrams, we must draw hydroxonium ion. Actually, we must draw hydroxonium ion. Gains a proton to form hydroxonium ions. So it becomes water is a proton acceptor acting as a base at that place. You come it is just an example. So in the forward reaction, we must, in a reaction, one must be acting as a base, the other one must be acting as an acid. Sawa? So inert kama base. HCl donates a proton to form chloride ion. So inakuwa proton donor. In that case, the HCl is an acid, which we have said is a proton donor actually in the definition. Iko sawa mpaka hapo? Are you understanding something? This one is just an example, but I know I'll repeat it somewhere else as we continue with this topic. I didn't want to teach a lot. In the backward reaction, let us just, maybe we finish in the backward reaction. Hydroxonium ion is an acid because it will be now doing the opposite. And then the chloride is a base. Mumeelewa kitu hapa? Let me just ask if you have understood something since we started. Are we okay from where we started? I mean, if an exam now is given, because I'll give you some few questions.
But hiyo ya nyuma, I think nairudia somewhere teacher. Sijaipata hiyo backward and the forward.
Yeah. This one actually is an example only to show. This one is an example to show you. The reason why I was only I wanted to. I don't even know. It is not even in your syllabus actually. What I just did is not in the syllabus. What we are doing in the syllabus is this one. You see what I yenye iko hapo. What you see now, we say an acid is a proton donor, and we say now a base is a proton acceptor. That is what we do. The reason why I normally introduce the other one, the reason why I normally introduce this one is because we have what we call the forward and the backward reaction somewhere up on mbele, where we'll talk now more about something being a proton donor and something being a proton acceptor. I hope that one better now, Maura?
Yeah.
Yeah. So don't be worried about this one. I am going to handle this one somewhere else, and I'll use easier terms because now at that time I'll be doing calculations. Actually, be doing some calculations. We'll be saying the factors that will affect. When you bring out the factor now, it becomes easier when you are dealing with this one with the factor. It is very easy to handle. Factors affecting the rest of reaction. It is very easy to handle that one. So unless there is a query, in this one so the other ones I think I'll pick from there. There's no problem. So basicity of acids, we already know the basicity of acid. Do we have to do it where we say monobasic, 1 hydrogen, dibasic, 2 hydrogens, tri, 3? You remember those ones?
Try.
I hope you remember those ones. Yeah, so it is the same thing. So when we meet next, the reason why I wanted is acid and base reactions. So I don't know. I don't think I'll start. I don't think I'll start something else for today. I think we can end it there unless there's a very burning question. This is a burning question. We can end it there. Mtu ako na swali? Because I didn't want to eat into your time. If there is no other question for today, thank you for attending this class. I'm really grateful. No, these have made sense if I was the only one in class. So thank you, Maura and Marietta. Thank you very much. Have a very beautiful weekend.
You too, teacher.
Yes, when we meet, we start
Enjoy
from
your small
acid-base
leave.
reaction.
So you will send the notes?
Yeah, I will send these notes. Can I send these ones that we just used there?
Yes.
Yeah, I'll send these ones. I don't know. Let me just forward to the group, and then I'll forward. Let me also forward all questions, all Form 4 topical questions. I forward them to the same group. Siko sawa. You just download, and then mukimaliza topic. You can even be doing revision. Then I look for Form 2, Form 1 and the Form 3. That is okay.
Yeah, iko sawa mwalimu. We really appreciate.
Yeah, thank you very much. You have a very beautiful weekend. Have a very nice day.
Thank you.